Hi, and welcome to this short live demo of our new reference app and example code for craniomaxillofacial surgery planning. Hope I got that right. So what we're going to do here is we're going to repair a large hole in the top of the cranium by creating a custom implant to cover the hole, basically. What we've got here is a console application. The source code is available if you're evaluating Polygonica or if you're a Polygonica customer. Just get in touch. And we've done it this way simply because there's quite a lot of user selection involved in these demos, and it's hard to reproduce that while recording a video. So we found it easier just to record the selection points and replay them with the exact same camera positions. But everything is done live, so Polygonica is computing the offsets and curves and selections and everything live in this demo. Okay, so let's get started. So here's the hole that we need to try to fill in. Now we could use Polygonica's curvature sensitive hole filling to fill over that, but with the sort of noise inherent in a scan and whatnot, we're not sure. It's quite a big hole, you might not get the best result. So another way of doing it is actually to say, well, hey, this skull's pretty symmetric. Skulls tend to be pretty symmetric. So the curvature on this side, on the right-hand side, is probably similar to the curvature on the left-hand side. So what we're going to do is take a copy of the mesh, mirror it with a -1 scale, and then align it with the original mesh using Polygonica's registration functions. Now you could... in theory, you don't need to use registration and alignment to do this. You could actually just do it by computing the offsets and sticking the mirrored model exactly where the original was. But that really depends on where you've decided the center of the coordinate system is, and also how that fits with the line of symmetry. If it's slightly off, then your results are slightly off also. So in this case, we've found that registration alignment is actually a more accurate way of doing it. So when I hit S, that's what we're going to do. So we're taking a copy and it's registered that copy. So you can see we've got this orange version of it here, which is the surface. This is like a proxy surface where we can now actually build the implant. Okay, so next step, we're going to select some boundary points around the curves. That's easy enough to do, just a loop selection, but worth noting that between these points is a geodesic curve across the surface, so it's a kind of minimum distance based across the surface. So we've selected those, and then that's it, we've created the skull cap. Well, okay, so going on behind the scenes there, what was happening was we imprinted a smooth curve, or we created a smooth curve, or created a curve, smoothed it, imprinted it onto the surface, introducing new edges where the curve is, and then found all the faces inside that region, which created a base surface for the implant. And then we've offset that to create a thickened surface, which gives us the actual solid material for the implant itself. And then we're going to do various smoothing, remeshing, and also add some bells and whistles to this. So what's first? So first of all, we might need some flexibility lines, flexibility cuts to, if things shrink or grow, then we don't want the cap to have too much stress placed on it. So we'll add some lines in that allow the cap to actually move and breathe a little bit, or move in and out a little bit. And that's just a case of selecting a line on the surface and using a Boolean subtraction using Polygonica to create those. And similarly, we might want to add an identifier to this so we don't put it on the wrong patient. So here's a Polygonica logo loaded from a DXF file, and then we're going to imprint that on there. I'm not going to move this just in case it messes up the camera position, but we'll look at it later. And then we get some not screw holes, perforation holes, again to allow sort of breathing, literally breathing this time, not flexing in and out. And then finally, the surgeon will, well, in fact, we've actually automatically selected these screw fixer positions based on the original selection. And then we'll create those. And that's basically the end of it. Very quick and easy to do with Polygonica. If I look here and just look at some of the features, so you can see we've got the embossed or debossed, embossed labeling, can't quite see from here. The other thing that's quite nice to look at is the fact that we've used blending to blend the edges here, so you've got a nice fillet on these edges, so there's nothing sharp that's going to damage the patient's skin. We haven't put screw holes here, but we could have done, but we have gone as far as at least putting a nice chamfer in there and whatnot. Okay, so that in a nutshell is building skull implants ready for custom skull implants for 3D printing using Polygonica. If you've any questions, then please don't hesitate to get in touch. You can contact us via the website. You can find us on LinkedIn, or if you're already in touch with us, contact the support team and they'll be happy to send out this code for you. Thanks for your time and thanks for listening.